Good morning, good afternoon, good evening. We are talking about estimating percents today, lesson 8. Ways that we can estimate percents are the 10% method and friendly fractions, both of which we explored in MSM2. You can see that I already have a few of these friendly fractions filled in. Half is 50%, a quarter and 3/4 we know, right? Because quarter, 1/4 or 1/4, 25%, the same as the value of a quarter, 25 cents. 3/4, 75%, just like 3/4 would be worth 75 cents. Now, how do I know that 1/5 is 20%? If I divide 100% by 5, I get 20. So each fifth is worth 20%, meaning 2/5 would be worth 2 20% or 40, 3/5 would be 3 20% or 60, and 4/5 would be 4 20% or 80. Then we've got the eighths, and sometimes people have a tough time with this, but if you think back to the fourths being 25%, well, an eighth is worth half of a fourth. So half of 25% is 12.5%. Now, if I double that, the missing fraction that's in here would be 1/4, 25%. Add another 12.5, 37.5%. Add another eighth, I'd be at 1/2 or 50%, which is missing in here, 4/8. 5/8, if I add another 12.5%, 62.5%. In here, we have 75% that's missing. If I add another 12.5% to 75, I get 87.5%. Now, sitting over here all kind of alone because it really doesn't connect to the rest of this set are the thirds. 1/3 is approximately 33%, but it's actually worth 33.3 repeating percent. That'll give you the full third. 2/3 is if I double that, 66.6 repeating percent. People will often round and use 67. Other fractions that are considered friendly are fractions where it's really easy to change from whatever denominator you have to a 100 in the denominator. So 3/10, if I do times 10 times 10, is the same as 30 hundredths, making it very easy to get 30% from 3/10. If I double the 9 and the 50, I get 18 over 100, and that's 18%. 25 goes into 100 4 times, so if I do times 4 times 4, I would get 48 over 100, which is why it's easy to get 48%. And we just said above that 20 goes into 100 5 times, so if I do times 5 times 5, I get 70 over 100 or 70%. So some fractions are considered friendly because of their relationship to 100. Now we've got the friendly fractions, and we want to use them to estimate the following percents. We know how to get the exact. We did that in lesson 7. We could use a proportion or we could use the multiplication. Now here, we're going to use multiplication, but we're going to say 32% is really close to 1/3. So instead of doing 32%, 0.32, we're going to do 1/3 of 73. Now 73, not very friendly. So I'm going to say 73 is really close to 75. Again, this is an estimate, so I don't necessarily have to use exact values. Why did I pick 75? Well, I noticed that I wanted a number that was easy to divide by 3, and 75 divided by 3 will give me an answer that's approximately 25. Notice I put the squiggly for approximately because I had to round the 32% to 1/3. I rounded the 73 to 75, so my answer is not exact. What is 23% of 80? So 23% really close to 25% or 1/4. So I'm going to do 1/4 multiplied by 80. And I noticed that 80 was easy to divide by 4. That should be 80 over 1. So 80 over 4 or 80 divided by 4 gives me an answer of approximately 20. What is 76% of 48? So I want a fraction that's really close to 76. 75% very close at 3/4 of times 48. Now you'll notice this one's going to take an extra step because I've actually got a numerator that's not a 1. I'm going to look and see if I can do any simplifying. The 4 and the 48, 4 divided by 4 is 1, 48 divided by 4 is 12. I have only 1s in the denominator, so 3 times 12 is 36, and it would be over 1, so approximately 36 for my estimated answer. Now, if you had seen 76% and you thought, I'm going to go with 80, your answer is going to be less accurate, but it's still an estimate, and you would be using a friendly fraction. Now, how about the 10% method? I think most students like the 10% method more than the friendly fraction method, but we will see. We'll take a little poll in class. Calculate 10% of 506. So if we want to find 10% of a number, we can do 0.17 times 506. We can also say what number out of 506 is 10%. Hopefully, you know that finding 10% of a number happens when you move the decimal point over one place, each place being worth 10%. So if we take the number 506 and we move it one place, we know that 50.6 is 10% of 506. Same thing happens when you multiply 0.1 or 0.10 times 506. So what do we notice? That we can just move the decimal point one place to the left, and that's always going to give us 10%. Now use what you know about finding 10% to estimate the following percents. So 21% is really close to 20. So if I want 20%, I need two groups of 10. 10% would be 9. So two groups of that, or 20%, would be 18. Now, how did I get that? 10%, I moved my decimal point one place, and then I just simply doubled for 20%. What is 39% of 452? Well, 39% is very close to 40%. So I'm going to need four groups of 10%. Now, 452, not all that friendly. I'm going to go with 450. So I'm first going to start with what's 10%. Move my decimal point over the one place. 10% is 45. So I need four groups of that. So basically what I'm doing is quadrupling or multiplying by 4. 40% would be 45 times 4, 180. So these are estimates. We would say about 18, and we would say about 180. When you get to the next section, though, you'll notice that 14% isn't super close to 10 or 20. It's more right in the middle. So we're going to use 15%. And instead of 82, something that's easier to take 10% of that's very close by is 80. So if I start with 10%, and I move my decimal point over the one place, that's worth 8. I need 15%, which means I really need another 5%. Well, half of 10% is 5%, and half of 8 is 4. So if 10% is 8 and 5% is 4, I can combine those for 15%, which is 12, and say that my answer is approximately 12. So you can use the 10% method to estimate things that end in zeros. You can also use the 10% method to estimate things that end in 5s. So 26% is very close to 25%. 109.7, messy. I'm going to go with 110. So 25%. If I know 10% is found by moving one place, I could double it for 20%. 22. Now my problem here is I need to get 25%. One way to do that is to find 5%, right? Half of 10% would be 5% or 5.5. And then I could combine my 20% and my 5%. 25% is about 27.5. All I did was add my 22 and my 5.5. There is another option, maybe a little less efficient, but I could go up to 30%, which is 33, and then say, well, if I want 25%, what's halfway? What's right here in the middle between 20 and 30? What's right here in the middle between 22 and 33? Halfway, or if I add 22 and 33, I get 55. Divide by 2, also 27.5. So two different ways that you can find things that end in 5%, and they do yield the same answer. I can find 20% and 5% and add them together, or I can find 20% and 30% and find their average. Last question on here. At a restaurant, the bill comes to $43.89. You typically leave a 20% tip. Estimate the amount of tip and find the total amount of the bill. Now, $43.89 is a mess to work with. I'm going to go with 44. And I want 20%. So 10%, if I move my decimal point one place, would be leaving $4.40. If I double that, 20% would be leaving $8.80. So that's just the tip. And the answer was estimate the amount of the tip, got it, and find the total amount of the bill, including the tip. I would add together my $44 and my $8.80 and say, I'm going to leave $52.80. And you're saying, Mrs. Frazier, it was $43.89. Why did you add 44? Well, most of the time when we're in restaurants, we don't use numbers that are kind of messy when we're estimating the tip and estimating how much to leave. And I probably wouldn't leave $52.80. I would probably actually leave $53 and say, okay, you got a little bit more than 20%, and that's fine. But the total is going to be potentially $52.80. You might say 53. You might even do the $43.89 and add the $8.80 and find the total that way. All of which are perfectly acceptable answers because you're estimating not everyone will have the same answer. See you in class.